Hello and welcome to What's New in Android. I am Chet Haase. I'm the lead of the UI Toolkit team on the Android team.
And I'm Romain Guy, and I used to work on Android, and now I work on robots.
So today we are going to tell you about a lot of the higher level features that are in the new release that was posted as an SDK about 3 weeks ago and is rolling out in system images today. So we'll cover a lot of the APIs. Some of the stuff you may have seen in the keynote, some of the material design stuff, but a little deeper on the API details there, as well as more of the system stuff and the system and platform overall. So that's us. If you want to follow us on G+ or Twitter, you can do so there. Let's talk about Lollipop. First, let's have a little context. We can talk about the devices, where they've come from. So you actually worked on this one. I did not.
I did, yes.
Tell us about the specs.
The specs, I don't even remember. I think it was a 300 megahertz CPU and something like 64 megabytes of RAM.
Because who would need more?
Yes, exactly.
So awesome device. Since then, we've had a few other ones added. I didn't show the Nexus 1 because I couldn't find a picture of it, but you sort of get the idea. A lot of Nexus devices out there, Nexus 10 holding sway over them all. Now we got the 6 and the 9 as well. So here's the Nexus 6. Big one. That is a big phone. And the Nexus 9, so you can get keyboard accessories, a little more full-featured and rounding out the platform in general, sort of giving more capabilities to users to get exactly the kind of Android device and form factor that they want, including watches, all kinds of watches. Watches with round faces. Who knew? As well as the Android TV platform, gaming platform, as well as general TV movie watching platform.
If you're curious about the Nexus 6, the Nexus 9, and Android TV, you can go to the booth downstairs. They have a few devices that you can look at and play with.
So, releases over the years, sort of taking us all the way up through KitKat and then on to, ta-da, Lollipop. So if we look at some of the interesting numbers, we don't really do the numbers anymore because it sort of gets to a certain level and it's sort of hard to even fit in your mind anymore. It's kind of irrelevant. But we can talk about some of the simple ones in Google Play, all the apps out there. So as of over a year ago, there were already 1 million apps on the Play Store and 50 billion apps downloaded. I think this means that everyone in the world has 5 apps. I think that's the way it works out. I have more, some people might have less, but in general, everybody has 5. On the devices side, we have 1.5 million activations daily. So this is like the new phones that are being turned on. Ton of new devices out there and over 1 billion users as of last June, which is such a big number. I thought it would help to have a little bit of data to help visualize that. So we can take a look at what the numbers were like in 2008. If you look down at that part of the graph there, that would be 0.
Well, no, actually it wasn't 0 in 2008, but it was...
It was a terribly small number.
It was
terribly small. At the beginning of 2008, there was 0. We're going to debate this for a little while up here. And then in 2014, there was 1. Billion. 1 billion. So I hope... Anybody have any questions on that? All right.
It looks like the graph from your community talk yesterday.
It bears no resemblance to other quantitative data I've used elsewhere. Also, we have a lot of stuff going on in the tools area. I hope you made it to the tool session yesterday by Tor and Jerome, where they talked about where things are at there. They are moving swiftly toward a 1.0. They're not there yet. I think they're at beta 9.3, 0.9.3, something like that. So they're at least approaching an asymptote, if not crossing the line soon.
How many of you are still using Eclipse and ADT? Raise your hands. They're so wrong. Yeah, you should really try Android Studio. Lots of new tools, better UIs for existing tools that you already know in ADT. And IntelliJ has a very, very good code editor.
Which is kind of why they chose it. Actually, a couple reasons. The code editor is quite good, and we also have capability of customizing the experience a lot more. Just the platform that we're building on allows us to do the things that we need to for a customized Android development experience. So hopefully you'll get a chance to try it sometime soon. In the meantime, we've been working on a lot of quality issues in the platform. So one of the main goals in getting out there originally was to get out there. And then once you're there, what are you going to do? Well, you want to actually make the users happy about the experience that they have. So we've focused on quality in a few different respects. First of all, there was the marketing came up with this name. I hate it. Project Butter. Back
you love it because you had this disgusting slide.
Yes, yes.
A chunk of butter on it.
It enabled many visual puns. Project Butter and Jelly Bean was about, we actually took a step back from features during that release, at least on the Toolkit side, and just focused on performance and smoothness and saying, what can we do to de-jank the platform, to make less jump cut transitions, to make things smoother, to improve the performance, to improve the animation smoothness and consistency, and basically just make it a nice, smooth, fast platform for everybody. In the next release, in the KitKat release, we had something called Project Svelte, which was about getting the platform down to a size where it would run reasonably on phones that are being sold in other markets where they're not coming out with the greatest hardware. They have, for example, a lot less memory. So if you have a 512 megabyte device and you have a platform that won't run in 512, then they're going to continue putting older releases on it. So this was an effort to get Android to the point where with new releases, you could still put them on reasonably cheap devices so that then those devices would also be upgraded to the latest experiences. This is one of the factors that's kept a lot of people running Gingerbread in the world because it runs in less memory. So
and that's why it's also possible to have KitKat, on your wrist.
And finally, Project Volta in Lollipop was about measuring battery performance and seeing what we could do there. We'll go into some of the details with battery stats later, so we'll see how some of that works. And then finally, also in Lollipop, we have the stuff around material design, which is making a better quality experience for the user around making a consistent user interface, something that they could easily understand and that apps could build around to make the platform and the applications and the overall experience more consistent and usable. So that is L, and now let's talk about some of the details. So first of all, so we saw a lot about material design. I won't go into the 4 pillars here, but the tangible surfaces and the beautiful aesthetic, the motion, all the animations in the system, and adaptive design. Hopefully you got all that. You took notes. You're all clear on all that stuff from the keynote, so we'll just move on. If you want to check out more information about that, you can certainly check out the material design spec site. And there's all kinds of dev bites and design bites and articles about material design as well as implementation details. So go to the Android developer site.
And actually, I want to emphasize the material design spec. If you're going to write an application with the material design UI, you should really go read the specifications to better understand how you should implement your animations and what colors to choose and so on.
So let's talk about the UI Toolkit area. So we sort of sliced and diced the platform areas in Lollipop into a few different areas. There's the UI Toolkit, there's the system UI changes, there's the overall platform and system, sort of the non-visual elements, and then there's graphics and media. So in the UI Toolkit area, what we mean by that is basically all of the views, all of the UI elements on the screen, and the graphics stack all the way down that's responsible for putting them on the screen. This is kind of where most of the implementation of material design came from. So when UX said, we want shadows, it was up to the UI Toolkit to figure out how to actually provide those. Similarly, for the theming, the ability to brand or colorize your assets on the fly or theme your assets. So all of that stuff sort of funnels through the UI Toolkit layer. So most of what we did in the UI Toolkit area for the release was specifically around providing these capabilities for material design. So on the theme side, we have the new Android.material theme. If you're running on AppCompat, then you would use the AppCompat theme, and it would automatically plumb through underneath so that if you're running on Lollipop, then it would pick the material theme for you on that release, and you would pick up all the attributes of that theme automatically. So there's new colors there, the colors that you're going to get in the standard widgets, the default themes that we come with for material. New icons as well, standard icons, some of the new vector drawable icons that we'll talk about later. Touch feedback ripples, so the user knows what's going on when they're actually selecting objects on the screen.
Actually, something that's important about the icons now, all the icons are grayscale, so they can be colorized very easily by the applications. And it's particularly important, we'll talk a bit more about that in a few slides, but it's very important for the notification icons. If you want to be able to brand your notifications correctly, then you should make sure that you give us icons that follow the guidelines.
And then finally, activity transitions are enabled. This is not to say that activity transitions are automatically going to kick off in your applications automatically, but rather that when you opt in to run an activity transition, that attribute is enabled by default on the Lollipop theme. So all you need to do is set up your transition and launch it, and away you go. Theme colors, this is the idea that now for the first time in Lollipop we have grayscale assets that are colorized dynamically either by the theme or you can set these dynamically in code if you choose to. So you can set some of these standard theme attributes, color primary dark, color accent. This is going to colorize, let's say, your action bar or your default backgrounds or your default UI elements on the screen to help you brand and colorize your overall application experience.
And we'll show an example of that in a little more details this afternoon. We have a talk called Material Witness, and we'll show a demo that makes use of those new attributes.
So dynamic colors, you want to take this?
Yeah, so the idea is that to make all the applications colorful, it can be very difficult for you to choose colors ahead of time. So the UX group decided that it would be great to make the apps be colorized dynamically. And in a lot of applications, you get content from your server or from the file system, like album art if you have a media application, photos if you have a social network, a gallery application. So the support library, the V7 of the support library comes with a new API called Palette that will extract a set of colors from a given bitmap. We'll again talk about that into more details this afternoon, but it's a very simple API. You can use it in just a couple lines of code. And you have an example here on screen. So we have 3 images, and the background color was lifted from those images automatically by the Palette API. You can also, we mentioned that you can tint colorize the UI. So the drawable API that's used throughout Android to render icons and bitmaps and so on offers 2 new methods. So you have set tint that lets you specify the color that you want for the drawable, and set tint mode that lets you change the blending mode. So the tint mode is called the Xfer mode in other APIs on Android. Tint mode is a much better name, and we should probably.
Xfer is awesome.
Yeah.
It's like Xmas. Yes. More abbreviations everywhere. All done?
Yeah, all done.
Okay. There are some new widgets that we enabled. Recycler View and Card View are both in the support library. So these widgets were enabled not just for the Lollipop release, but for any release prior to that, going back to V7. Card View, we talked about in the keynote this morning. It's the idea that it's a really simple container. You can actually do it on your own. The advantage to using Card View is it gives you a consistent look with other applications in the system that are also using the same card view. So it boosts the cards to a particular predefined elevation, so you get that specific shadow, and then there's a specific rounding to the corners on the cards. And other than that, it's just a standard container. There's padding on it, so the items inside that container are offset from the edges by certain amounts. And
calling Recycler View List View 2 is a bit of a simplification. Recycler View can do a lot more than List View 2. It supports multiple layouts. Of course, you can create a list view, but it can scroll in 2 directions, horizontally and vertically. A lot of people have been asking for that over the years, so now it's there.
You could have done it before. It's just to scroll horizontally, you just needed to rotate the device by 90 degrees. I can go into this more later if there's questions about that.
Anyway, it's definitely an API that you guys should take a look at. It's much better than List View, which is not hard to do.
So actually, it's both more and less than List View. So yes, it's a little incorrect. It's a gross, disgusting simplification there. It offers a little bit less in that it doesn't offer some of the same capabilities that List View has that should be there in the full span of time for Recycler View, such as there is no cursor adapter yet. But what there is the ability to plug in all these things into Recycler View in a way that you could not with List View. So with List View, you had the layout that it gave you. It was a vertical layout, and you're done. And if you wanted any other layout, basically you were rewriting List View on your own. With Recycler View, you can plug in arbitrary layout managers. We give you 3 layout managers. By default, there's a linear layout manager, horizontal and vertical, and grid layout manager and stacked grid. So there's a lot of capabilities just in the ones that we give you, but you can also just write a layout manager without having to go to the trouble of writing the whole adapter view as well. And the adapter, it doesn't have a cursor adapter right now. You could write a cursor adapter for it. It also comes bundled with item animations by default. So instead of creating tens of DevByte tutorials to tell you how to animate list view because it was so painful.
Come on, it only took you as a framework engineer, what, a couple of days of work to make it work? More?
Each one of those?
Yeah.
Yeah. So instead, we actually bundled in item animations by default. So now when you add or remove items, they'll automatically fade out and the items around them will move in. And you can do more advanced and custom animations if you want to take a bit more code, but at least it comes with some basic capabilities for free. So on the graphics side, we talked about this a little bit in the keynote this morning, the idea of having elevation so you can boost views into this volume that sits above the view hierarchy plane, and then we automatically cast shadows. It's realistic shadows based on the concept that there's an area light source, it's a rectangular light source that sits above the view hierarchy plane, and cast shadows onto these views to give you this nice soft shadowed effect. So actually, as you move views around on the screen, you can see it's very subtle, but you can actually see the shadows change over time because you're changing the views relative to position to the light source and the screen, so the shadows adapt naturally and realistically. And then there's also the ability to shape the views, so you can tell us what shape the shadow should be as well as what shape the view should be. So we allow clipping to very simple shapes like rounded rectangles and circles, and then we'll automatically clip those views as well as shaping the shadows appropriately. Animations, so activity transitions, again, talked about it in the keynote. The idea that, so there's actually two distinct parts. In the keynote, we talked about the shared element transitions. The idea that, let's say you're in a list of albums and you want to click on one of the albums and you want to go into the list of songs that's in that album. Wouldn't it be nice if you could actually share the album and transition, bring the user from one part of that experience in the application to another? So that's the shared element itself, the album view that we're going to share between these different activities. But we also have the other elements there. So there's the items that are going away that can animate out. You can crossfade them. You can have them explode off the screen, whatever you want to do. And then we're going to share the elements. So there's sort of a two-stage transition of animating the shared element into the new activity. And then there's the new items in the new activity that are going to animate in. So sort of these 3 to 4 different phases of the activity transition. So the option to have shared elements, but also just the capability to just do richer animations on both sides of this. You can contrast this with the current window animations, which are very simplistic by design. Basically, we animate the windows themselves, so we can slide them in, we can fade them, we can scale the windows, but the window manager has no idea what the contents are inside of the windows. So what we have with activity transitions is the ability to go into the activities themselves and say, what are your views like, where are they laid out, and how would you like to animate them in? And this builds on the capabilities of the transition package that was added in KitKat, which already gives you the capability to say, here's where everything used to be, here's where it is now, automatically animate the changes. It's basically taking that to the next level and saying, do exactly the same thing, but across activities, which you could do already if you knew a lot about writing Android animation code. So this simplifies it and gives a nice consistent API to do this fairly powerful capability.
You have DevByte videos, right, on how to do that on older versions of the platform?
Yeah, there's a DevByte called Custom Activity Animations. So you can see the technique for doing it, which is basically popping up a transparent activity window and then passing information through in bundles and doing appropriate animations. So it was possible, but it was non-trivial enough that we did a DevByte around it to explain how you might do that. This not only makes it easier and more consistent, but it also makes it more performant, gets around some of the problems with transparent windows, and it also makes it possible to do across application boundaries. So this isn't just going into a sub-activity, but you can actually also launch a completely unrelated activity and still share elements between them through the named transition elements. There's also new capabilities in animations, both in curves. So we make it much easier to create time and motion curves to get much more realistic and organic motion on the screen so that elements simply aren't moving in a straight line across on the screen, but instead they can move in a natural curve. And they can also use more natural timing curves using quadratic and Bezier quadratic and cubic Bezier curves, which designers like. It allows them to express much more natural motion.
You also had an example of doing curved motion, right? In the demo. Anyway, it was also really complicated to do, and took a framework engineer a couple of days to do it. So now it's easy.
Yeah, so there's an article that I posted probably 3 years ago about how to do curved motion, and it builds on the animation APIs in 3.0, and it uses custom type evaluators to evaluate this thing that's not simply a value, but it's actually a two-dimensional value over time. So again, it was possible, but it was not trivial, which is why we wrote an article about how to do it, and why we then later spent time in actually creating APIs to make it much easier to use in general. Oh, and here's a couple of demos, a little seizure-inducing demo on the left-hand side, so you can sort of see some of the shared element stuff there. So there's two parts of this here. One is that some of the elements are going away, so there's a sort of cross-fading out. That's the first step in an activity transition, is animating the old non-shared elements out and then sharing this element. So we're going to pop it up. That's just selecting the item, and then we say, okay, we're launching this new activity, and then it's actually going to share the element between the activities, take this bitmap representation, toss it over the wall, animate it into place where it's going to be laid out in the new activity. And then finally, the other thing that we did in Motion was the idea of having these animated reveals. So this is the demo that you'll see later in the material witness talk, if you come to that, where we expose a view over time with a circular reveal. We say, here's the center of the reveal circle, and here's how I want you to animate the radius, either expanding or contracting, and then we're showing or hiding the view over time. Lots of work going on in icons in a couple of different ways. So first of all, we can see there's probably a really subtle one here, the ripples on the left. So you can see sort of the touch feedback ripple as the user is touching the button, and you're getting some sense of not just that the button is going into a selected or a pressed state, but also where the button was actually pressed. So just more rich feedback to the user about what's going on in the screen. And then the other capability, which is new as of the public release and was not announced at I/O because, frankly, it wasn't ready, is vector drawables. So this is the idea that you could take definitions of icons in vectors instead of just bitmaps. And you can not only represent those static icons, but you could also animate them over time. So if we looked at the code over on the right, which is based on an engineering demo, which is horribly ugly. Don't make icons that look like this.
It looks like one of your demos, Chet.
So I would write a demo like that. Don't base your demos, your real code, on my demos. But all of these are vector assets, and they're being animated over time. We'll show a little bit about how that works in a second here. An important element about vector icons, so there's two parts to this. One is it's only in Lollipop, so you're probably not terribly interested in it yet because obviously you have other releases to support for at least the next 3 weeks. Yes, you still have to worry about the previous releases for now. We're considering how we might do something like this in earlier support library, but it's rather tricky just given the way that resources and drawables work. So don't hold your breath on that one. But going forward, now that we have it in the platform, eventually you can imagine a world where you could actually ship assets that are based on vectors instead of PNGs, and now you no longer have these bitmaps that are created specially for all these different resolutions, but instead you have icons that are created once that are automatically going to scale to the resolution that's necessary at runtime. So hopefully much more memory efficient, both in terms of download and runtime memory. So a good thing overall in the long run. Sorry, it's only in the platform for now, but eventually that will become more and more significant. And then the other capabilities that we added are in these two new animator classes. State list animator, I mentioned in the keynote. It's the idea that instead of just a state list that says, here's what a button is going to look like as it enters and exits these different states, we can actually also specify what the animation is that takes it there. So we can specify that as we go from the pressed to the unpressed state, we want to animate translation Z. So we can then, this is actually how button is written, is using state list animator. So when you press on it, we're actually animating translation Z, so it pops up toward the user. The shadow expands a little bit to give an indication of that movement in elevation. And then animated state list drawable is the idea that you could animate between different states using PNGs. Instead, if you want to do a more traditional keyframe, you can actually do that now to animate between states of view as well.
Yeah, that's what's used, for instance, for the checkboxes or the radio button. When you check a checkbox, you'll see a nice little animations that's done with the animated stateless drawable.
Here's some code about vector drawables. I don't want to go into too many details here, but you can sort of see the basics that we have this vector object.
What I love about the syntax is how obvious it is what it's going to look like on screen. This is actually the SVG syntax for path. So you can, any tool that can output SVG code, you can just copy and paste in that path data attribute, and you'll get the same result.
So we don't support full-on SVG, which is one of the reasons why we're not just doing SVG, but we use their format because it already existed, it's convenient. This is basically what you want to do anyway, is you want to be able to move, and then you want to be able to define curves or lines. It's a straightforward way of representing the type of path data we wanted anyway, so we just sort of latched onto SVG format as a convenient way to do that. However, we don't support things like open paths or self-intersecting paths or some of the various infinite attributes that SVG enables. So it's fairly limited, but at least allows the capabilities for these simple icons and icon animations that we're talking about.
And again, to be clear, we don't expect anybody to write that by hand, the path data user tool. There are many good tools.
So here's the structure. So the previous one was just the vector drawable. So that would be like the static asset if you just want your icon to look like this thing when it's on the screen. But if you actually want to animate a vector icon, then this is kind of the way it works. We have a new resource file called an animated vector drawable. And that defines two things. It says, okay, here's the static icon to reference, which is the vector drawable that we saw on the previous slide. And then here are the animations that I want you to use when you're animating to different states.
Nested scrolling is something that we've been thinking about for many years on Android. We've got thousands and thousands of questions on how to put a list view inside the scroll view, or a scroll view inside the scroll view, or list view inside the drawer. So now there's support for that kind of stuff in the UI toolkit. This API is a little bit complicated, so you should refer to the documentation. But basically, the idea is that if you reach the end of a scrolling container, for instance, a text view or a scroll view, and you keep scrolling, that container can send the events to the parent, so that then the parent can start scrolling. And you can see that used throughout the new Material Design UI. In a lot of applications, you will bring up a drawer, and without lifting the finger off the screen, after the drawer is done showing up on screen, the touch events will go to a list or scroll view, and scrolling will keep going.
So it's a standard way for you to basically pass information up and down the parent hierarchy when there is extra scroll to be done. So if you reach the end of your container, but you know that some parent above you is also sitting inside a scrolling container, then you can pass it up and say, okay, I'm done. Here's the extra scroll information that you can act on. This was possible before, but ended up being really hacky because you were overloading the meaning of the touch gestures and the motion events, and got into kind of bad situations. You could do it in very specific situations, but as a general purpose tool, you were sort of using the same hammer for every kind of motion event on the screen. So we constrained this to add capabilities specifically for nested scrolling.
So the render thread is something that was introduced early on in the development of Lollipop. Up until Android 5.0, the rendering was done in the same thread as all your UI code, so layout, measurement, your logic, everything was happening on the same thread. So every time the app was doing something that would block that thread for a little bit of time, maybe it was a mistake, like doing some I/O operations on the main thread, or maybe it was just doing a complex layout, it would simply block all the animations, and it will contribute to the jankiness that you could see in some of the Android applications. So now all the rendering happens on a separate thread, and some of the animations are driven entirely by that thread. So for instance, the new REPL animations work like this. So even when you launch a new activity, there's a lot of work happening when you launch an activity. We have to inflate all the layouts, we have to decode all the bitmaps, and then run all the logic of the activities on create method. And that used to pause animations, and you could see it when you were touching a list item in previous versions of Android. We had these, fading animations on our list items, and you could see it getting paused while the new activity was being launched. Now in Lollipop, you'll see that the REPL animations keep running. They're perfectly smooth because they run on a separate thread. And I think that you guys have a lot of plans to move more animations on that render thread in the future.
Yeah, I think a lot of the capabilities that we added in Lollipop around this were more about plumbing that we can build on for the future. A lot of what we do on the Toolkit team is about optimizing things and making things faster automatically for applications. Applications can and should do a lot on their own because we're very general purpose at the Toolkit layer. But the more optimizations that we can make, the more everybody benefits. So render thread was about doing that. It was about removing responsibilities from the single thread and doing what we could on another thread, and then posting more capabilities there over time as we can figure out appropriate APIs to do that. So ripple animations as well as reveal animations are the first two instances of that, where it's just this opaque animation. There is no callback into user code, so there's no requirement that it needs to be on the UI Toolkit thread. So instead, we take the information about the animation, we send it over to the render thread, and it happens autonomously over there, regardless of whatever else is going on that's stalling the UI Toolkit thread.
And actually, I think what Chet meant is that the job of a UI Toolkit engineer is to make things slow and then optimize them so we can look good.
Don't tell anybody. Shh.
Try it at home, it works.
There are various things added to the support lib. It's been a general trend in the toolkit area in general that when we can add things to the support lib instead of the framework, we will, because it's great if people can use these capabilities on all releases, or at least as many back as we can go for particular capabilities. We can't always do that. When we add capabilities for, let's say, shadows, we can't possibly add that to support library because we actually needed to change the core rendering engine. That rendering engine doesn't exist in that form on previous releases, so we could put the APIs there, but you can't do anything about them, right? We can't actually display shadows in previous releases. So some things are necessarily constrained to live on platform releases or to be released in platform releases. But other things like widget capabilities, if it doesn't build on any capabilities that are new in the platform in that release, why not put them in the support library? So we tend to do that when we can. Card view and recycler view that we talked about are great instances of that. We also had the palette utility library that we talked about here and in the keynote, the ability to extract that color data from images. It has nothing to do with any particular release. It's just dealing with standard Android bitmaps and new APIs, so we put that in the support library as well. Rounded bitmap drawable was one of the capabilities that we needed in card, so we added that to support library. View property animator compat is something that we needed for the new item animations that are in recycler view, so we added this there. A lot of the new APIs that we'll add to support library are representative of what we do in view property animator compat, where yes, the API is there and you can call into the API across multiple versions. However, if the underlying capability doesn't exist in previous versions, it'll simply be stubbed out. So at least you can write your code more simply. And then on previous versions, it's going to do what it could anyway, which is essentially nothing. If the view properties aren't there, if there is no translation X property on a view in Gingerbread, then it won't do anything. But at least you could write your code in one single place instead of, conditionally compiling it or conditionally running it based on runtime version. And then finally, notification compat. So some of the new notification capabilities that we'll talk about are also available in the support library.
So there's an update to Webview. Android is now tracking the Chromium Webview as close as possible. And the biggest changes in this version of Webview are the support for the new some of the open standards. So Web Audio, WebGL if you want to do OpenGL in a web application, and WebRTC for video streaming.
One of the things that they announced recently also was the ability to update from the Play Store. So you could actually get your Webview updated asynchronously from platform updates. Kind of exciting. There's no specific announcements on when this would happen, but at least the capability is there for you to then upgrade your web experience on Android between platform releases. So in the system UI area, we had various enhancements. One was document-centric apps. If anybody's actually run Lollipop, when you run recents, you may see something you hadn't seen before, like your different Chrome tabs represented as different windows in the recents area, or different, like if you're in Gmail Compose, that may come up as a separate task from the Gmail reading application. Or various applications can basically opt into this idea where you no longer have these monolithic tasks where there was only sort of one recent thing that you could go back to. Instead, it's the idea that you can launch your activities into different tasks that then be represented separately inside of recents. And then there's simple APIs to interact with that capability. Notifications underwent some changes. So there is the First of all, the theming for material, let's give it a card look, let's give it some shadows, let's make it look standard on the new Lollipop platform. There's also the ability to provide accent colors for your icons, so we'll automatically tint the assets, as we were talking about before.
Yeah, and this is why I mentioned earlier that you should really follow the guidelines for notification icons. So notification icons should just be white on a transparent background, so we can effectively use them as a mask. And that way we can apply the accent colors properly in the window shade. If you try to use colorized icons, then it's going to look really bad.
And we'll also, if you give us small icons, we'll automatically badge the larger icons. So just more capabilities for branding your application, making it look good and appropriate on the platform. And then all the stuff that you knew and loved before, expanded notifications and capabilities for interacting with notifications to perform actions in the applications. Heads-up notifications, this is really cool. If you're in the middle of a game and then someone that you don't want to talk to then, like, I don't know, your spouse, calls, then you have the option to actually not take the call. Previously, there were full-screen intents that would launch, like your phone would ring and all of a sudden you're swapped out of your very important game activity to then deal with the phone. And the game was already lost, and then you figure you should probably answer the phone because you've been gone for a while and you're feeling kind of guilty. So now you have the option instead. You'll get a heads-up notification on these full-screen intents, and you can automatically dismiss without destroying your in-game experience or your other full-screen activity experience. So there's various triggers that we use to know whether to pop up a heads-up notification as opposed to actually swapping into the new activity, higher priority, or if it's full-screen intent or whatever. So the phone call is a great example of that. You no longer get the full-on phone launching instead of whatever application you needed to use at that time. There's also something new. If you've used Lollipop, you'll see that you have notifications on lock screen, which is cool. So now you just take your phone out of your pocket and you can see whether there's anything that you actually need to deal with, and then you can log into your phone and deal with it there. One of the tricks with lock screen notifications is you may not want other people to see those notifications, right? So if you leave your phone in a bar and someone picks up that phone, what are they going to be able to see about your private information on the lock screen? So there's this idea that we have of spheres of visibility, which is sort of two-sided. There's the developer side of it, where they need to define what is appropriate to display in public about this notification, and then there's the user side of it where they can decide what they're comfortable with as well, and they can put further requirements and constraints on that. So for example, I have corporate email on my phone. I'm fine with people seeing the headers from my personal email on the lock screen, but I'm not fine with people seeing the headers from corporate email. And you can specify this both as a developer, the information that you're publishing publicly, and as a user, the information that you're happy with other users seeing in your lock screen. So from the developer side, we have the idea that there's public information, this notification is fine, you can display this notification fine on the lock screen, there's no problem with this. You have the idea that there's private information, okay, this is stuff that people need to log in past the lock screen to actually go in and see. And then you have this third area, which is, well, this is private information, let's say the corporate email example. So yes, the header of that email was private and confidential, but you can at least display information that there was a new email in the corporate account. So you can say this is a public version of this private notification, and then it will use that on lock screen instead. And then finally, there's the super secret side, where these are notifications that need to stay within the lock screen boundary completely.
All right, let's talk about what we actually like, media and graphics.
Yay.
So one of the big change for mostly game developers is the addition of OpenGL ES 3.1 in Lollipop. So with both NDK bindings and SDK bindings, how many of you use OpenGL? All right, so there's one person who's going to care about what I'm going to say next. So of course, OpenGL ES 3.1 is compatible with the previous versions. It adds many very interesting features. For instance, compute shaders, which let you do compute operations on the GPU, which can be a lot more efficient than the CPU, depending on what you're doing. Many shading language improvements, things I'm really excited about, like stencil textures and indirect drawing. You probably don't care. If you want to use OpenGL 3.1, you should put this line in your manifest. so that the Play Store can show your application on compatible devices. You can also deal with this dynamically if you have a correct fallback capabilities in your application. We also introduced something called the Android Extension Pack. OpenGL ES has a lot of extensions that are available to developers, and they can be a little difficult to use because just to use one function, you have to query one extension, and every phone comes with different extensions. It's the same on desktop. So the Android Extension Pack gathers 20 extensions and gives them all available at the same time. They're guaranteed to be on any device that has Android 5.0, and you can just query that extension pack name, and you'll be able to use all the extensions. Some of those are actually very important. Things like tessellation, geometry shaders, atomics. These basically give phones capabilities that are almost on par with existing video game consoles. So we should be seeing in the upcoming month or year really, really good-looking 3D applications. Camera and audio, we finally released the Camera 2 API, which adds a bunch of new features. One of them is the ability to capture images as RAW files. So instead of getting a JPEG, you get the actual sensor data in a format called DNG. DNG is an open format from Adobe. So applications like Lightroom, Aperture, Photoshop understand DNG. It can be used by many, many applications out there, and gives you, much better quality and a lot more control over image processing. One of the big features of the Camera 2 API is the speed. So on KitKat, the fastest you could capture images at was about 3 frames per second. And now the Camera 2 API can do that at about 30 frames per second. And the best part is you can change the settings of the camera between every image and you will still retain that 30 FPS. Before, just changing the ISO or switching to HDR would take a couple seconds. So it's a lot better. And finally, the teams have been working a lot on audio latency in the past couple of years, and now they focus their efforts on input, so lower latency audio input. A bunch of other media enhancements. The introduction of the media session, it's an API that makes it a lot easier to deal with media playback. So before, every media playback application, so your podcast application, Google Play Music, Spotify, whatever, they all had their own player, their own way of dealing with media transport controls. So now there's a single location. You can get callbacks about what other applications are doing with the media controls, and it should lead to a much better media experience on Android. Media browser, you can also get access to the media content exposed by other apps. There's a media service as well that you can implement if you want to provide your content to other applications. And media projection is very interesting. It lets you capture the screen. So in your application, you can start an intent that will ask the user if they want to grant you the permission to capture the screen. So imagine if you're writing a social network application, you can use this to share the screen with somebody else across the network. You could also use it just to capture the screen as a video for debugging or whatnot. The way it works is actually pretty simple. You get the content of the screen as a surface. And the surface can be used as a texture. It can be used as a source for video encoding. You can use it in a 3D environment. There are many things that can be done. And are we doing audio capture? I thought that it wasn't done by this API. Okay, check the documentation. I'm not sure about the audio part of it. PDF renderer, so we had the ability to generate PDF. So I think it was introduced in KitKat. So you could take a canvas and everything you draw into that canvas would be rendered as a PDF. So now we can go the other way around. If you get a PDF from the user in your application, you can easily render it into a bitmap, so you don't need a third-party library to be able to display and render PDFs anymore.
So it's sort of an implementation detail of printing, which came online in KitKat, I think.
Or 4.3, some time ago.
Okay. So we needed that for print preview, but we also exposed it as a general API, so you can get access to PDF for your bitmaps as well. So art. So art came online in KitKat?
Yep.
As an optional runtime that you could use, the Android runtime, so you could optionally turn it on and see whether your application's crashed or not, which is usually a good thing to know. So in the meantime, they were working hard at fixing the various problems that resulted from that, just the different way that it manages memory. And as of Lollipop, it is not only the primary runtime, it is the only one. So Dalvik is gone, and now you can use Art, or you can not use Android. So much better runtime in general for various reasons. So ahead of time compilation, so there's higher levels of optimization that we can enable. Smaller GC pauses, I think this is the one that certainly I care most about. If you look at logs in KitKat or on any Dalvik implementation, and then compare those to what you're seeing in Lollipop, you're going to notice something pretty significant. Like normally a full GC pause prior to Lollipop, you get a pause of 15 to 20 milliseconds pretty regularly.
That would be a fast pause.
Yeah. So, it figures it needs more memory, so it needs to collect the stuff that's there, and then it goes out and does that thing. It stops the world, and then it goes and collects things. And that took a while. And on Art, what you see is pauses of like 2 to 3 milliseconds instead, which is huge. In the world of graphics and UIs, we want 60 frames a second. We want animations to be smooth, which means we're displaying new content on every frame, which means we have 60 frames to display in a second, which means we have 16 milliseconds per frame to do all the calculations necessary and then get the pixels there onto the screen. So if you're taking up 20 milliseconds just for a GC pause, the user's going to notice it, because we're going to lose a frame right in the middle of it. So if you can instead take up 2 to 3 milliseconds, again, hopefully not that often, but it's going to happen at some point, then all of a sudden we have a lot more time in which to do the other stuff that we need to do in a particular frame, and then hopefully we can keep up to 60 frames per second. So one of the ways that they did this was by enabling a separate heap for bitmaps. So previously, as of 3.0, we moved all bitmap allocation into the Dalvik heap so that we could manage the memory more intelligently instead of making developers manage it on their own in excuse me, in the native heap. So you no longer have to recycle, but it means that when we needed to collect things, we would need to do a finalization, fairly expensive. One of the problems was we were putting everything in one single heap, and that meant that small allocations and big allocations both had to walk through this one single heap, and the heap would get necessarily more fragmented because you'd have these huge blocks of memory taken up by these bitmaps. So what they did with Art was to say, okay, all bitmaps can live over here, all large objects can live in the large object heap. And it makes it much more efficient for both allocating as well as collecting those objects, as well as walking the normal heap where we don't have large objects instead. If things get less fragmented as well, because you don't have these huge objects taking up space in the normal heap. The other thing that Art did was to enable actual defragmentation. So this doesn't happen while your activity is being actively used, but when it goes into the background, we're actually able to go into the heap eventually and collect things and move them around appropriately. This is one of the things that we needed applications to test against in earlier releases, because some developers were making bad assumptions about whether memory would actually stay pinned or not. So we believe those issues are gone now, but in the meantime, that means that when the activity goes in the background, we can collect the heap, move things around, compact it, and make allocations and deallocations much more efficient the next time you go back into
the defragmentation is very important, because I've seen many developers run into an interesting problem where the application crashes with an out-of-memory error, and when they check the VM stats, they see they still have 20, 25 megs of heap available, and that was because the heap was so fragmented, there was not a single spot where they could put their array or the bitmap. So that solves this problem.
Project Volta is about tracking information on the battery to find out where the battery was going and then improving it to the extent that we could. But along the way, we developed these utilities, which you can also use yourself and see if your application is being a good citizen. So you can run a new command for dumpsys called battery stats. And then you can use this tool that you can get off of GitHub called Battery Historian, and it'll give you a graphical display, kind of like systrace with the battery information about how much power was being used by all the different processes running on the system at the time.
And there's an example here. Sorry, there's an example here of how to use this battery stats tool. So we won't go into the details, but you should just follow the steps on your Lollipop device and see what you can do to improve your application's battery life. Stop clicking. Jobscheduler. So that was after analyzing, the battery usage of various applications, the team came to the conclusion that new APIs were needed to help applications do a better job at managing their hardware resources. So there's this new API called Jobscheduler, and the idea is that sometimes, a lot of applications will want to sync data over the network, for instance. So we had APIs like the alarm manager, where you would wake up every 30 minutes, and maybe you would check, is the device plugged into the wall? Am I on Wi-Fi? Am I on a 3G connection? And the problem is that every app was doing that, and those were the actually properly written applications. So instead of doing all this work manually, having all the apps do the same thing over and over again, now you just describe the conditions that you want before your app is woken up. So in this example here, we're creating a job info, and we said that we want an unmetered network type, so which means probably Wi-Fi. We want the device to be charging, and we want the device to be idle. So if you leave your device on your bedside table, after a while, your application will receive a callback, and you'll know that you'll be able to do your sync operation. So the job info builder lets you specify a lot of things. You can also say that you want to be woken up in a few hours or in a few minutes, that kind of things. So again, take a look at this API. It's very important for your application. Documentary, in KitKat, there was a new way to access storage, and both for users and for developers. And we got a lot of feedback about this new API because it was not possible for applications to get access to the entire SD card, for instance, for phones that have that separate removable storage. So now there's a new intent. You can ask the user to pick a document tree. So if they want, they can choose a specific folder on the SD card that they want to give the application access to, or they can give access to the entire SD card. And that will persist across reboots. So it's basically the user granting permission to this application for a particular folder. And that folder could be anything. It could belong to another application. It could just be a folder you've created yourself. You can also use this new get external media dirs on the context object. It returns a file array of all the sorry, it's a place where you can put your media files. And we already had a similar API called external files dir. It was a folder where the application was supposed to put its media files, but then you had to talk to the media store to tell the media store that you were putting images there or video so that they could show up in the gallery or other media applications. So get external media dirs will do what the old API was doing, and on top of that, we'll manage the media store automatically for you. Multi-networking, you can request a specific network for your application. So, your phone today can connect on a Bluetooth network, on Wi-Fi, on 3G, and depending on what your application wants to do, you might want a specific kind of network. So you can send a request, and you will receive a callback as soon as one of those networks is available. It's also an API you can use if you want to do graceful handoffs between networks. So if you're downloading something over Wi-Fi, and the user, leaves their home and they get out of range for Wi-Fi, they're going to switch to 3G, then you can get a callback from the connectivity manager, and you can recreate the stream on the new network much more easily than in the past. Bluetooth LE, it was introduced in Android 4.3. The big change in Lollipop is that now your device can act as a peripheral device for Bluetooth LE. So your phone could act as a heart rate monitor, for instance, for another device. So applications can now use the Bluetooth LE advertiser to advertise their services to other devices. You can also scan for services around you. Enterprise and education. So there's the new concept of managed profile. It's not surfaced in the UI yet, and it's the idea that you might want to use the same app in different contexts. So, for instance, email for work and email for home. So you would end up with two instances of that application with completely separate storage for security reasons. And a big feature for users is the new screen pinning. So you can enable that from settings. You go in settings security. You can enable pinning there. And when pinning is enabled, you can go in the recent screen. So you just press the recent button. There's a little pin at the bottom. When you tap on it, you won't be able to exit that application until you enter your pin or your pattern. So if you want to let someone use your phone because they need the web browser to go do something, you can make sure that they will will only be able to use the web browser and they won't be able to get access to the rest of your device. Applications can also request pinning programmatically, and in that case, the user won't be able to exit the pin mode until the application releases the pin request. So that's about it for today. We have a few minutes for questions. So if you want to grab the SDK, if you don't have it yet, d.android.com. You can also find Android Studio there. And we have a second talk this afternoon called Material Witness, where we'll go into more details of material design, how it's implemented, how it works, how to use it. And we'll go through a couple of demos that we wrote.
So we do have time for questions. It's a little hard to see past the lights, so if you have to get our attention, just throw something at Romain. Yes?
An object animator that's animating a property I define, does that setter get called on the render thread?
So the question is, with the render thread, if you have an object animator that's calling a property that you define, so you have your own setter in your object, does that get called on the render thread?
No. Next question. So a more complete answer is object animators are a great example of something that we cannot put on the render thread yet, because we don't know for any given object animator whether there's going to be interaction of the application for that animation. So for example, if we send an animation over there, but you've added an update listener, or you need to know when that animation ends, immediately you're going to start some other things, so you're trying to carefully choreograph things. If it's on a separate thread, careful choreography is sort of not in the cards.
Well, and this is actually the main reason why we did not implement a render thread before. It's because the guarantee we were making earlier was that all the methods on views would be called on the UI thread. So suddenly we cannot call them from an arbitrary thread and expect your applications to work. And in Lollipop, because there are so many built-in animations like the ripples or the circular reveal, then it made sense. And those are not, cannot be customized by the applications themselves. So then it made sense to create a render thread.
So it's not actually specific to your use case of having a custom property. Any object animator is in the same situation. In fact, view property animators as well. So basically, it's only those two animation examples that we used of the reveal and the ripple animations that can live on render thread right now.
Because even without a custom property, if you animate the alpha on the view, you can make a subclass of the view and override, set alpha, and there's no way for us to know that this is happening. So again, for backward compatibility, we could not do that before.
So I would expect future APIs and capabilities that allow developers to then set animations on that thread, or to somehow opt into the use case of running them on the render thread instead, because otherwise we can't make enough assumptions about those animations.
Does pin mode catch intents to third-party applications?
I missed that. Sorry.
Application from pin mode, and there is image.
Oh, if you're in pin mode and you start an intent, what's going to happen? You're going to have to enter the password or the pattern to exit the application.
So I have a sort of a personal question. Do you like the new icons in the navigation bar?
Oh, so personal question: do we like the icons in the new navigation bar?
Next question.
They match the style really well, and I love material design.
Icons are such personal taste.
Over there?
Java 8?
I'm not on the Android team anymore.
I have nothing to say about that right now. Yes.
How is the performance for SDK drawables that you categorize for
Right. How is the performance for the SVG drawables or the vector drawables? We are using software rasterization, so we use our old software rasterizer to draw paths just like we do for any other paths.
Not quite. It's a little more complicated. Simple shapes like rectangles or rendered rects or lines we can detect, and those will be drawn very efficiently at the GPU level, but any path that's more complex than that will go through software rasterization and be turned into a texture.
And so if you're using a static drawable, like regardless of how that's rendered, it's going to end up as a texture, and we copy the texture around. That's very easy. If you're animating a drawable, then that is going to end up being more expensive. This is one of the reasons that we would recommend if you're using animated vector drawables right now, we're just talking about icons. We're talking about these little tiny things on the screen, and it's fairly efficient for doing that. I could see hardware accelerating these in the future. There's a lot of hard problems to solve along there. But in the meantime, it's really appropriate for small icons. I wouldn't do full screen animated vector drawables at this point, or you'll probably suffer.
Yeah, or if you do, make sure you test on older devices to make sure the performance is correct. Because on today's devices, on the Nexus 5 or Nexus 6, it's going to be fine. But you know, your app is going to run on more than those two devices.
Does the new vector drawable stuff take that into account and try and align stuff to a pixel grid?
So the question is, with vector drawables, a common problem is that your paths will not correctly align with the pixel grid all the time, and the system doesn't do anything in particular to fix that problem. The tools, so tools like Sketch on macOS or Illustrator have a way to align the path to the pixel grid. So instead of fixing it in the renderer, you can do that in your tool, and that helps a lot. The problem is that doing it in the renderer, it may or may not be what the user wanted, so it's very difficult to solve that automatically.
So I probably glossed over when talking about vector drawables that it would be nice, in some idealistic future to just use vectors for everything. There are a lot of cases where the designer wanted something specific at that resolution anyway. So this is one of those cases where, yeah, maybe there is something where like the alignment wasn't exactly what you wanted, or they just wanted, when that icon was really tiny, they wanted a different representation of it anyway. So you should probably check out what your icons look like at different resolutions and make sure that you're happy with the results. And one more question? Yes? That question was already asked. That was another Java 8 question, and I'll give you the same answer I did before, which is I got nothing to say. All right. Thank you for the rerun. All right. Thank you.
Thank you very much.